Hello everybody, and welcome back to another mathematics video. In this video, we'll be looking at ratio. And at the end of this video, you should be able to do a few things. You should be able to simplify ratio. You should be able to evaluate questions involving ratio. So let's head straight into the first part of this video. So first things first, what exactly is ratio? When we talk about ratio, what are we talking about? Now, ratio is a way to compare two or more quantities, showing their relative sizes of these quantities in relation to each other. So if you have two quantities and you want to show the relationship between these two quantities, how one quantity is related to the other in terms of quantity, I'm saying quantity a lot, we use ratio. So let's look at how ratio is written and how it is represented. So as I said earlier, ratios represent relationships between quantities, showing how many times one value contains another. Now, ratios are written three ways. First of all, it's written using the colon. In the first example, we have 3 to 4, and that is how that is read, 3 to 4. And also, a ratio can be written as a fraction. The 3 to 4 is written as 3 over 4, which is showing 3 to 4. And also, it is written in words, 3 to 4. So those are three ways we can represent a ratio, using the colon, a fraction, or even in words. So for example, if there are 2 apples and 3 oranges, and if you want to show the ratio between apples and oranges, we can say the ratio of apple to oranges is 2 to 3. This is saying for every 2 apples, we'll have 3 oranges. And that is the whole concept of ratio, showing the relationship between two quantities. So let's look at the parts of a ratio. Now, a ratio consists of terms separated by colons. For example, in the ratio 3 to 5, and that is how that is read, 3 to 5. 3 is the first term and 5 is the second term. However, ratios, we can also have more than 2 terms. We can have 3 terms. Like in the example, 3 to 4 to 5. This is saying for every 3 of something, there is 4 of something and 5 of another something. So it is not limited to 2 quantities only. You can have 2 and more quantities. So now that we have an understanding of the basics about ratio, let's look at how we can simplify a ratio. Now, ratios can be simplified by dividing both parts or all the parts of a ratio by the highest common factor. Just like in a fraction, if you want to simplify a fraction, you can see a ratio is simplified using the same way. And as we learned earlier, a ratio is represented as a fraction, so that is why. So for example, the ratio 10 to 20 can be simplified by dividing both the 10 and the 20 by the highest common factor, which is 10. So 10 divided by 10 will give you 1. And 20 divided by 10 will give you 2. So instead of saying 10 to 20, this can be simplified to 1 to 2. And by simplifying these ratios, it makes it easier to interpret and to use. For example, if you say 10 to 20, that is saying for every 10 of something, there's 20 of another something. Instead of saying that, we can say for every 1 of something, there's 2 of another something. So 1 to 2 instead of 10 to 20. Now let's look at the concept of equivalent ratios. Equivalent ratios are equivalent if they represent the same relationship. For example, in the previous example, we had 1 to 2. That is the same as 10 to 20. So those can be considered as equivalent ratios because they represent the same relationship. And then in this example, we have 3 to 6 is equivalent to 1 to 2 because they both represent the same proportion. If you break down 3 to 6, that can be broken down to 1 to 2. They both represent the same relationship. So to find equivalent ratios, we simply multiply or divide the terms by the same number. So for example, if we have the ratio 2 to 3, we want to write an equivalent ratio to this. So all we do is we multiply the 2 by the same number, let's say 2, and we multiply the 3 by 2. So this will give us 4 to 6, which is the same as 2 to 3. And that is how we have equivalent ratios. So this concept is important if we want to simplify a ratio or to show that two ratios represent the same proportion. Let's look at ratios in real life. So ratios are most times used in real life to compare quantities that we use in real life. For example, if you want to mix flour and sugar to make probably some bake, in the recipe you will have, for a certain amount of flour, you'll put this amount of sugar. And this will help you to make more bake of the same quality because the ratio is just different. So for example, in the ratio 2:1, this is for flour to sugar. For every 2 cups of flour, you'll put 1 cup of sugar. I don't know how that bake will taste, but this is just an example. Now let's look at a question that involves ratio. So this question says, in a classroom, there are 12 boys and 16 girls. What is the ratio of boys to girls? So we have 12 boys and 16 girls. So the ratio of boys to girls would be 12 to 16. But of course, we know we can simplify this ratio. So 12 and 16, they both have a common factor of 4. So 12 divided by 4 would be 3. And 16 divided by 4 would be 4. So the ratio of boys to girls would be 3 to 4 after we simplify it. And let's move on to another example. So the question says, share $180 in the ratio 2 to 3. So the thing about when we want to share ratio among certain quantities, we must first, the important thing for us to do is to find what is the value of one share. We have to find what is the value of one share, and this will tell us how much would be the share for the 2 shares. So we see $180 is shared in the ratio 2 to 3. So in total, 2 to 3 will represent a total of 5 shares because this will be 2 plus 3 would be 5. So in total, the 180 has to be shared in 5 shares. So for us to find what is the value of one share, we divide the 180 by 5. So the value of one share, so we can say one share is equal to 180 divided by 5. So 180 divided by 5 would be 5 ones 5. 5 into 180 would be 36. So the value of one share would be 36. So if the value of one share is 36, then the value of 2 shares, which is the first part of the ratio, would be 2 multiplied by 36, which will give you 72. And then the value of 3 shares would be 3 multiplied by the value of 1 share, which is 36, is equal to 108. So the value of 3 shares would be 108 and the value of 2 shares would be 72. And that is how we share $180 in the ratio, using the ratio 2 to 3. Now if you add up 72 and 108, you will get 180. And that is the answer for this question. Now that we have an understanding of ratio, let's look at an exercise to review the concepts that we discovered so far. So the first thing, simplify the ratio 18 to 24. So we want to simplify 18 to 24. So 18 to 24, we can divide both the 18 and the 24 by the highest common factor, or by a common factor, which is 6. So 18 divided by 6 would give you 3. And 24 divided by 6 would be 4. So this here would be 3 to 4. When we simplify 18 to 24. Now let's look at 25 to 35. So 25 divided by a common factor between 25 and 35 would be 5. So 25 divided by 5 would be 5. And 25 divided by 35 would be 7. So this ratio, when we simplify it, would be 5 to 7. Now let's look at the last question, 45 to 60. So 45 and 60, they have a common factor, the highest common factor of 5. So 45 divided by 5 would be 9. And 60 divided by 5 would be 12. So when we simplify 9, so when we simplify 45 to 60, this will be 9 to 12. And that is the answer after we simplify 45 to 60. And let's move on to another concept, equivalent ratios. So the first one says, write two equivalent ratios for 2 to 5. So 2 to 5, the first thing, 2 to 5. So an equivalent ratio to this, all we need to do is multiply both parts of the ratio by a common number. So let's multiply this by 2. Let's multiply this by 2. So 2 2s, 4, 2. 5 2s, 10. So a common ratio, an equivalent ratio would be 4 to 10. And we could also try multiplying the ratio 2 to 5 by 4. So you multiply both parts by 4. So 2 4s, 8, 2. 5 4s, 20. So two equivalent ratios would be 4 to 10 and 8 to 20. Let's look at the other one, 7 to 3. So we can multiply the 7 by 10 and the 3 by 10. So an equivalent ratio, one equivalent ratio would be 7 times 10 would be 72. 3 times 10 would be 30. And then we can also multiply 7 to 3 by probably 11. So 7 times 11 would be 77. 2. 3 times 11 would be 33. So, and these would be two equivalent ratios for 7 to 3. So it's simple, just multiply it by a common number. Let's move on to some ratio questions. So the first question says, distribute $300 in the ratio 4 to 6. So the first important thing that we learned earlier in this video is that we need to discover what is the value of one share. So the value of one share, we see we have the ratio 4 to 6. So 4 to 6, the total share would be 4 plus 6 would be 10. So this 300 has to be shared between 10. So we find the value of one share. So we can say one share is equal to 300 divided by 10. This 0 cancels to that 0. So the value of one share is $30. So $30 is the value of one share. So to find the value of 4 shares would be 4 multiplied by 30, which would give you 120. And then to find the value of 6 shares would be 6 multiplied by 30, which would be 6 3s 18, so $180. So you can put in the dollar signs. So for 4 shares, it would be $120, and for 6 shares, it would be $180. If you add up 120 and 180, you will get back the 300. So we saw how, so we can see how the $300 was shared. So the next one, divide 500 candies among 3 children in the ratio 2 to 3 to 5. So first of all, the process will be the same. We need to find what is the value of one share. So we need to add up all of the ratios here. So this will be 2 plus 3 plus 5, which will give us a value of 10. So we see the total candies. We have to share this 500 candies among 10 shares. So 500 divided by 10, this will give us 1 share. So 500 divided by 10, so this will go with that. 50 divided by 1 would be 50. So the value of 1 share would be 50. So to find for each individual share, which would be the 2, the 3, and the 5, this would be 2 times 50, which will give you 100. And then we use the 3 now. So 3 times 50 would be 150. And then the 5 times 50 would be 250. So for the ratio 2 to 3 to 5, the share would be 100, and this would be for 2 shares, 150, which would be for 3 shares, and 250, which would be for 5 shares. And if you add up all of that, you see you will get a value of 500, which would represent the 500 candies. So our last question now as it relates to ratio. So this question says, so a bag contains red, blue, and green balls in the ratio 2 to 3 to 5. If there are 30 green balls, calculate the total number of balls in the bag. So we have some information here. So we have red, blue, and green balls, and this is shared in the ratio 2 to 3 to 5. So we have red, blue, and green. And this is shared between the ratio 2 to 3 to 5. So we know in the bag we have 30 green balls, and the 30, this is shared among 5. So since we have 30 green ones, and we know this 30 is shared between 5, remember the most important thing for ratio is to find the value of 1 share. And from the time you can find the value of 1 share, you can answer any question as it relates to ratio. So what we can do, we can find the value of 1 share. So we take the 30 and we divide it by the 5. And 30 divided by 5 would be 6. So 1 share would represent 6 balls. Now, to find the total number of balls in the bag, it would be, we have to find the total number of shares. So you know 2 to 3 to 5 would give us a total share of 2 plus 3 plus 5 would give us 10. And the total number of balls in the bag would be 6 multiplied by, because that's the value of 1 share, the 10, which would give us 60. So we can say, therefore, there are 60 balls in the bag. So the most important thing that we did here, we found the value for 1 share. So we used that information of 30 green balls and we divided it, and we divided that 30 by the 5, because the green balls were shared in the ratio 5. So 30 divided by 5 would give us 6, and that now is the value of 1 share. That is what 1 share represents. And then we take that value of 1 share and we multiply it by the total number of shares, which should be 2 plus 3 plus 5. And then that now would give us a total number of balls in the bag. And with that, it has brought us to the end of this video. I trust that you now have a good understanding, and this was a nice refresher on ratio. Until then, I'll see you in the next video.